So hello and welcome friends to our channel Intro Mech, and here we discuss about basic mechanical engineering concepts. So guys, we have started our new series regarding the digital engineering tools, and in our previous session we have seen some of the tools which are offered by Festo. Now in our upcoming sessions we will see some of the tools which are offered by SMC. Now SMC is also a world leading manufacturer of automation tools like actuator, grippers and many other things. So here I'm not promoting any kind of brand or manufacturer. My main aim is to let you know that there are a lot of digital tools which are available freely on the internet, and you can utilize them for your system optimization. So without wasting time, let's get started. Before going into details, you should know that what will you learn out of this video. So very first thing is what system inputs are required. So whenever you guys design some kind of product or say mechanism, it is very important that you should know what are the inputs that are required for the designing. Let's say you want to design a system in which you have to push a 10 kg load. Now what is the system input here? You know that 10 kg load you want to displace. So this is the kind of system input, and many times it happens that the system is complicated, so you are not sure like what kind of system inputs are required. So at the end of this video you will know that how this digital engineering tool will help you to know what are your system inputs. Then the second part comes is like what output parameters are required to be considered. So whenever you design something, let's say our example 10 kg of load you want to push, so which kind of cylinder you will pick, what will be its bore size. Now the bore size is the output parameter, so this digital tool will help you to decide which bore size you should select, and it will give you some output calculations which will be compared with your input parameters. So that is very important factor that you should know, that whether my system is safe or not, whether my selection is say proper or not. And then the third thing is how to use this digital engineering tool effectively to check the feasibility of your design. So yes, at the end of this video you will definitely know that how this digital engineering tool will help you to find out the optimum solution, because whenever you go to design something there are n number of different options you might have. Then you have to compare and choose. So what if you have a tool which is readily available, and it can give you the results within uh, a very less time. So yes, all these things you will understand at the end of this video, so don't skip the video, watch it until the end. So let's get started. So you just have to type SMC product selection tool and you will find model selection software. Just click on that. You will enter into smcworld.com site, the model selection software, and here you could find lot of tools to select from. Equipment list you will find like air grippers, actuators, power clamps and so many things. Some of the calculation softwares are also there, and you don't even have to log in into this. This is totally free. So today we will see the rotary actuators. So just click on that, the window will open, the rotary actuator model selection software. So it will allow you to select the optimal size of rotary actuator. Just click on the model selection, it will show the target selection series over here. If you want to specify the series you can specify it, or you can keep it as it is, so that you will have lot of other options, right? And the precautions you can read on what are the basis, what are the assumptions for the calculations, you can read. So just click on next button. So here now you could find the selection of purpose. You have to select the purpose, rotary plus clamp or only rotation or the sweeping. So you have to select your purpose. So let's take rotation. Now select the mounting orientation. You have to select like horizontal upward, horizontal downward or vertical. Let's pick horizontal and upward. Click on the next. It will select the body shape of the input, body shape input method. the load shape, sorry, select and input the shape, input the parameter directly, arbitrary composite. If you know the parameter value, you can directly input, or else we can have select and input the shape so that it will calculate the size. And last one, also we have arbitrary load saved files, some input files are there. Let's have the select and input shape. Now it will ask the type of load shape, a single or a compound shape or a gear transmission. Now let's go with single shape. It will ask the rotation center and the load center of gravity, whether they are like same or eccentric. So now let's select the eccentric system. It will select the load shape, whether it is a shaft or a plate or a disc or a sphere. So let's have a rectangular plate. Now here is the system. We have to give the inputs. It will show the nomenclature, the mass of the plate. Now let's select the mass as 2 kgs. Then the distance LA between the axis of rotation and load center of gravity. So this is nothing but the center of gravity of your part and the axis of rotation, the distance between that. So let's consider it is as 50. The length A, the total length of the part, let's assume it as 300, and length B as 100 mm. Now we have given the inputs to the system. Just click on the next button. Then we have to give the rotation angle, that means through how much angle we want to rotate the part. Let's say 180 degrees. What is the rotating time? This is related to your cycle time, in how much time you want to rotate that part. Then the supply pressure, let's have 5 bar, and the rotation time, let's have 1 seconds. And then the ambient fluid temperature you can give up to 60 degrees. So click on the next button. Now it will show some of the series which are available. You can select any one of that. Let's select the type of, let's have rack and pinion type or vane type. Again, in vane type it will ask you the cylinder series. So let's select the CRB on standard type. Now here you could see that it shows that there is no product satisfies the condition. So again you have to filter out the options, right? So we have to add an external stopping mechanism. So that is the input given by the that is the output, that is the session given by the system. Let's select the type, then the cushion, then the size. We can restrict the size if we want. Then the rotating angle we can have, and then the magnet. So there is only one option over here, but it is asking again the product is not suitable. We have to consider an external stopping mechanism. So as soon as we select the external stop mechanism, shock absorber, the product is okay. And what is the meaning of that? When the product rotation angle is larger than the required rotation angle, we have to consider a external stopping mechanism, because we have to stop the product like in between. So that's why it was earlier showing the error, and as soon as we select the shock absorber, now it is the part code is correct. So this is how the software helps you to consider all the parameters. If you have like skipped something, or if you are unaware of something, the software tells you. Now, these are the explanation of the total judgment. You can see what are the conditions and all those things. You can read out those things, and then just go to, this is our model, right? Now let's have a look for rack and pinion type table. Then again you will have a lot of options. So let's select the basic type. Again you can see over here the options available. Two options are available, right? So we can have a cushion. The options will get reduced to 7 cases. We can restrict the size also if we want, right? Let's have 70, or just keep it as it is, and magnet with auto switch. So we have 7 cases, and we have explanation of the total judgment. So we have selected one product, then we have the port thread type we can select, and the port location. The port thread type, let's select uh, the NPT threads. So this is our final selection, and now we will have all the data over here, which type of rotary actuator, the pneumatic rotary actuator we have selected, all the dimensions we can see, what are the mounting locations, what are the output condition, what are the input condition, what are the specification of the selected model. Here you can see the allowable range and the input values, the calculated values you can see, and these input values are within the allowable range of the product, and that's why it got selected. So you can check what is M, what is the radial load, then what are the moments and or the axial loads. So all these things you can read. The required torque, you can see what was the required torque and what is the allowable range of that system. So all these things you can read over here, what is the meaning of everything, so that it becomes easier to understand what we have selected, right? So you can also read some precautions, and you can download the CAD. Then you have the catalog also, you can just download the catalog in any language you want, let's say in English. So the catalog will get open. You can print the document, you can save the document as PDF. You can also have the CAD. If you go to the CAD, you can see again you can have a digital catalog or normal catalog, and all the other options are available. You can download the 3D CAD to use it into the software. So this is about the rotary actuator model selection software offered by SMC, and this is totally free. So this is it guys for our today's session, and I hope you got some new knowledge regarding the digital engineering tools and their benefits, and also what are the system inputs for designing the system, why those inputs are important, then what are the system outputs, and how to compare these parameters for the optimal selection of your product. So all these points we have covered, and if you have any doubts, please do write into the comment section. We can discuss over there. Until then, keep intro making. Don't forget to subscribe the channel and hit the bell icon for the upcoming videos. Thank you for your patient listening. Thank you.